Hi, reversing a linked list is an important algorithm that you might have to implement when solving other more challenging problems. Let's dive into it. From a high level, a linked list can be represented as a chain of values. We are given the first node, from which we can arrive to the second one, from the second to the third, and so on until we reach the very last value. Programmatically in JavaScript, a linked list can be represented as a series of objects, where the key value represents the value of our node. So for n1, the value is 1, for n2, value is 2, and so on. And the key next represents to what node this arrow points to. So in case of the first node, the arrow points to node 2. So we set next to be equal to n2. For the very last node, n5, we set next to be equal to null to show that there are no nodes coming after n5, and symbolically we represent it by having an arrow 2, this symbol of a circle with a line going across it. Given the very first node, we can find any node in our linked list by calling .next enough times. So n1.next is equal to n2, n1.next is equal to n3, and so on. Taking this idea further, if we were to denote the very first node in our linked list with the variable current, we could repeatedly call .next on current to go through every single element in our linked list. Typically, when we want to do something repeatedly, we would use a while loop. So while we are able to call .next on current, and we can call .next on current as long as it's not equal to null, we're just gonna set current is equal to current.next. When we will be reversing a linked list, we would need to iterate through it. However, first, what is a reversed linked list? A linked list that has been reversed still has the same nodes as the original linked list. However, these arrows now point into the other direction. So now in the reversed version, the last node of our original linked list becomes the very first one, and the very first node becomes the last node in the reversed version of our linked list. To illustrate this point further, if I were to label our nodes by variables, n1 through n5. In my original linked list, I will have that, say, n3.next is going equal to n4. But in the reversed version, n3.next would equal to n2. So if the nodes of a linked list are labeled, we would simply need to execute the following code to get the entire linked list reversed. However, in a typical linked list problem, we only get a pointer to the very first node, and we don't have the nice labels to work with. So when we iterate through the linked list, we typically have our variable current, which points to our current node. And then we traverse the linked list, and the variable current goes through every single node in our linked list. Now let's pretend that our algorithm is working correctly and consider what will happen at each step as we traverse through our linked list. So when current is at node 1, we would want to remove the link from 1 to 2 and set 1 to point to null. Then as we go on to the next step, we would want to erase the link from 2 to 3 and create a link from 2 to 1. Then we can go on to the next step. To do these steps programmatically, what exactly would we need? Well, first of all, we need to have knowledge of where the previous node is. In this case, when current is at 3, the previous node would be at 2. Then we would be able to set current.next is equal to previous. This step in the code will erase this link and set the link to be from 3 to 2. Now I will consider how I can update my variables for the next iteration. So previous would need to go to the current one. So I can specify it by having the arrow from previous go to 3, while the current one needs to go to 4. However, I no longer have the link from 3 to 4, since now the link from 3 goes to 2. But I need to have knowledge of node 4 to go on to the next iteration. So I can get around this problem by by having another variable, next. To update current to the next iteration, we would just say current is equal to next. So this is how we will start the next iteration. I know that since I will need to update current to equal to next, the first step would be to define my variable next. So in code, I would write const next is equal to current dot next. And now I am free to break the link from node 4 to 5. So I can execute this line of code, which will erase this link and have a link going from 4 to 3. And then I can execute these 2 lines of code. And now I am ready to start the next iteration. Now I will execute the written steps. So first, I will define my variable next to be equal to current.next. Then moving on to the next line, I will set current.next to be equal to previous. Then previous will get set equal to the same value as the current. And current will get set to be equal to the same value as next. So these look like precisely the steps I would want to execute at each iteration, so I can enclose them in a while loop. Notice that since next is local to the while loop scope, whenever I go to the next iteration, I lose my variable next and I have to redefine it again. Now I will consider the termination condition for my while loop. I want the while loop to run so that current could go through every single node of my linked list. But notice when current becomes null, such as in this case, the entire linked list is already reversed, so we don't need to keep running our while loop. And in fact, if I were to call current.next when current is null, it would throw an error. So I want my while loop to run as long as current does not equal to null. However, I can do a slight simplification here. Since when current is not null, it evaluates to a truthy value, and whenever current is null, it evaluates to a falsy value. I can remove the comparison and just run while as long as current has a truthy value. So the condition that is currently drawn is precisely the condition at which my while loop will exit. And notice that previous actually points to the start of the reversed linked list. So if I'm solving a problem where I need to return the very first node of the reversed linked list, I could just return previous at the end. And now I will consider the initialization condition. So when we started running this algorithm, we started out with current being equal to the very first node in the linked list. So that would translate to defining current to be equal to head at the very beginning. However, notice we also need to define previous. On the first iteration, we wanted to reverse the link from the very first node to point to null. So if we were to set previous to be equal to null, the first iteration of our while loop will do exactly what we want. And actually, this code is precisely the code that will reverse a linked list. I have copied the code over to leetcode, and now I will submit it, and it gets accepted. So this solution runs in linear time since I have to go through every single node of my linked list, and the space complexity is constant.